Okay, so I'm going to do a few different types of curves and show how I set up my Excel file. Here are my student grades. First, I calculate the average for all the grades equals average. It's a little low, right? And you can do this as a percentage or just a general number, a decimal. Okay, so the first is a linear fit curve. And here's the idea. I'm going to find the minimum grade that any student earned and the maximum grade. I do equals min, M-I-N, highlight the student grades, in the parentheses, close the parentheses, and then equals maximum grade, highlight the student grades, their scores. And I'm going to say my 56, the student who got a 56, her new score is a 65, let's say. And the 91, I'm going to change that. I'm going to curve that up to a 94. So I'm giving more of a bump to the person who did poorly. She gets more points back, and the person who did worse, the person who did well gets fewer points back. The rationale behind this, and usually students can understand this, the rationale is that if I gave an easier test, this 91, she was already kind of maxing out, so her score wouldn't have gotten that much better. But the person who got a 56, there was a lot she was not getting. And so there's a lot she could have potentially gotten correct if it had been an easier test. So her score will improve more with an easy test, whereas the high grade will improve less had I given it an easier test. So that's the theory. Okay, so I want to set up, these are right here. These are the raw percentages, and I want to convert those raw percentages into curved percentages. And so I'm going to set up an equation, a y equals mx plus b linear equation, where I want to plug in as x. I want to plug in for x the raw percent and get out as y. The output should be the curved value. So my raw percent, those are my x values. The curved, those are my y values that I want to be the output from my equation. So again, the y values are the curved, that's my output, equals slope, slope times x is the raw percent. I plug in these values, and then plus the y-intercept. Okay. So I have to find the slope and the y-intercept so that I can plug in the raw percent into this formula and calculate the curved grade. Okay, so how do I find the slope and y-intercept? I do equals slope, open parentheses. The formula requires the y's go first. So here are my y's, right? Here are my y values, and then comma, x's go second. Okay, I hit enter. And then I do equals intercept. For the y-intercept, I do equals intercept. Again, y's go first, comma, x's go second. Close parentheses. And here are my slope and intercept. So now I'm going to calculate the curved percent, and I'm going to use this equation, right? So equals slope. So I click on the slope cell with that value, I reference the cell, times raw percent, that's this for student 1, plus the y-intercept is this. And I have to fix these two references because when I copy my formula down, I don't want those references to move down. So I'm going to put the dollar sign in front of the letter and the number, letter, number. And I hit enter, and then I copy this down. And you can make it a percentage, obviously, if you want, percent. And then I calculate the average. I'm just going to move this equation over. Whoops. There we go, average. Okay, so why did I do it this way? Well, now I can actually just go in and I can say, okay, what if I make the highest grade, a 96? Ooh, that brings the average up to an 84. What if I make this a 63? Okay, now it's an 83 again, So that's why I like referencing the slope and y-intercept in these equations. Okay, K-curve. Here's the K-curve. We're essentially giving the student 15% on her test just for showing up. And then the remaining 85% is based on the score she actually earned. So you say equals, she's getting 15%, and now you're going to add some additional portion based on what she earned here. So the remaining portion that you have to weight, there's an 85% weighting that remains. So you take this grade and you multiply it by 0.85, except don't do 0.85, do 1 minus the k value to get the 0.85. So that way, if you change this to 0.1, then now the student score, B2, the student's raw score, will be weighted by 90, the remaining 90. Okay, and then I have to fix my reference, the k value, that cell, I have to fix that reference. So dollars in front of the letter, the number, and then I copy this down, and let me calculate some averages, and then copy that over. And I've already made these percentages, I guess. Okay, and it's the same thing, right? The 56 goes up to a 63, but the 90 is only going up to a 90, the 91 is only going up to a 92. So it's the same theory. The worse you did, the more bump you get, right? The last choice, the last option is just a flat curve. Teachers will look and say, okay, highest score was a 91. I'm going to make that 100. How do I do that? By adding 9 percentage points, so 0.09. And then they apply that same curve. They add 9 points to everyone's grade. Students usually will see that as fairer, even if it's not necessarily fairer. But that's one that many teachers use just because, it's easy to explain to students. So this is the curved percent. There is another curve, which is you change how many possible points there were on the test, divide by a smaller possible points. But I really avoid this because it gives more bump to the students who did well and less bump to the students who did poorly. So I don't do this, but here's how it works. So here are the points students earned on the test. The total possible points was 60, right? So how do I find their percent? I take the points they earned, I divide by the 60, and I fix this reference so that I can copy my formula down without changing the 60 down, without referencing lower cells. So I got Control-C, Control-V, copy-paste. And so here are the percentages, raw percent. And then I'm going to calculate the curved percent. The curved percent, instead of dividing by, new total possible, so I have some new total possible points, which is like 58 or something, right? So instead of taking their raw points, instead of dividing by 60, I'm going to divide by 58. Divide by 58. And I fix this cell reference, and then I take away some decimal places, and I copy, paste, and let's get the average. Okay. And you can make these percentages if you'd like. So, but look at this. Look at what happened. The person who got a 91, I'm adding 3% to her score. But the person who got a 56, I'm only adding 2% to her score. And if I make this more drastic, if I divide by like 56 or 55, then now the person who had a 91, I've added 7 points. But this kid down here, I'm only adding 4 points. So this is really not a curve I use because it kind of does the opposite of what I intend for a curve to do. Now here's the thing, like when I give tests, usually they're hard tests. So it makes sense for me to curve the scores as though, it makes sense to curve the scores so that the new curved grade shows what they would have gotten on an easier test, right? I give them the grade they would have gotten if the tests were easier because the tests are so hard. If you felt like the test was reasonable, maybe that's a reason to do a flat curve. It was a reasonable test. You guys should have done well on this, so I'm not going to worry about giving more points to the kid who failed. I'm just going to give the same 9 points to everyone. Flat curve. That's an easy way too.